Every few months, an extraordinary claim in physics captures the global news cycle. We are told a miraculous new material or reaction has been discovered, only for the story to quietly dissolve months later when the physical reality fails to materialize. While the fundamental logic of the scientific method remains the most reliable path to truth, the modern network used to disseminate those results has introduced systemic flaws into the public record. Research is expensive. To keep their laboratories operational, scientists must consistently secure external funding, a process that increasingly rewards those who can attract broad public attention to their work. The institutions hosting these scientists face a similar pressure. Universities actively promote their most provocative findings to attract high-performing students and bolster their academic prestige. Finally, the research is handed over to the press. Media outlets and science journalists operate in an attention economy, structurally incentivized to maximize clicks by stripping away caveats. When these three forces align, they create a high-velocity feedback loop. Nuance is discarded. Highly tentative, unproven hypotheses are accelerated through the press cycle and presented as established fact. This chart tracks citations over time in the scientific literature, comparing studies that are eventually replicated against those that fail. The data reveals a clear structural distortion. Studies containing faulty, unreplicable claims receive a massive influx of ongoing attention. On average, these unreplicable studies accrue 153 more citations than studies grounded in validated data. The system actively rewards the noise. To understand how this distortion operates in practice, we have to look past the headlines and forensically deconstruct exactly how data is misrepresented in 4 recent highly publicized cases. We start at the intersection of quantum mechanics and computational physics, where abstract mathematical theories are modeled. On December 1, 2022, the journal Nature published a cover story announcing that a holographic wormhole had been created inside a quantum computer. The claim triggered an immediate frenzy online and in the press. The reporting heavily implied that researchers had successfully opened a literal, traversable tear in spacetime within a laboratory setting. The hardware utilized for this experiment was a standard quantum computer. In terms of raw processing power, the calculations it performed could be executed on an ordinary smartphone. The researchers did not produce a physical anomaly. The experimental output was a mathematical representation, a flat schematic generated by code. They had taken a highly speculative, unproven theoretical model of gravity and mapped its equations onto a quantum processor. You could draw a sketch of a rocket ship traveling to the moon on a piece of paper. Pointing to that sketch and announcing to the world that you have successfully executed a lunar landing is a misrepresentation of the experiment's actual utility. By conflating a simulation of hypothetical math with the manipulation of physical reality, the communication chain manufactured a breakthrough out of thin air. In observational astrophysics, detecting signals from the early universe requires hardware of staggering complexity, sifting through an infinite ocean of background noise. In 2014, researchers operating the BICEP-2 experiment announced they had detected a specific polarization pattern in the cosmic microwave background radiation. The stakes of this detection were absolute. The polarization was attributed to primordial gravitational waves from fractions of a second after the Big Bang, serving as the definitive proof for cosmic inflation theory and the quantum nature of gravity.
The sensors were functioning correctly, and the signal itself was real. The failure occurred in the team's rush to attribute the source of that signal. Driven by the intense desire to secure a historic discovery, the early findings were broadcast to the press before the specific variables could be rigorously isolated and verified by outside teams. Subsequent observations from independent satellites proved that the signal did not originate from the dawn of time. It was caused by ordinary galactic dust floating in our own Milky Way. The local dust passing in front of the telescope's array perfectly mimicked the exact fluctuations expected from primordial gravitational waves. Rushing unverified data to a press conference guarantees that experimental artifacts are broadcast to millions as established scientific laws. This exact same dynamic drives the hype around material science. Recently, a preprint paper claimed the discovery of LK-99, a room temperature, ambient pressure superconductor capable of transmitting electricity with zero resistance. This timeline and bar chart tracks the history of known superconductors. Over the past century, researchers have progressively mapped new materials with higher critical temperatures, but always requiring extreme high-pressure environments to function. For LK-99 to operate at room temperature and ambient pressure, it would require an immediate jump in critical temperature of about 125 degrees Celsius over the highest-performing materials on record. The evidence required to debunk the claim was already present within the paper's own data tables. This split screen illustrates the published claims. On the left, the team's single plot charting resistivity versus temperature never drops to absolute zero, as a true superconductor must. Instead, it measures the resistivity in units of 10 to the minus 2 ohm centimeters. Plotted on that scale, a standard copper wire, which operates around 10 to the minus 6 ohm centimeters, would falsely appear to have zero resistivity. The visual evidence provided for the Meissner effect, the ability of the superconductor to expel magnetic fields and achieve perfect levitation, was equally compromised. In their demonstration, one edge of the LK-99 material tilts and physically sticks to the magnet. That behavior indicates standard ferromagnetism, which directly contradicts perfect diamagnetism. The media amplified the claim of infinite energy transmission, while ignoring the unit-scale errors and physical impossibilities sitting directly in the open-source data. Even when the data itself is accurate, the context of the experiment can be manipulated. Take the recent headline stating that scientists successfully produced a nuclear fusion reaction that generated more energy than it consumed. The public and the press universally framed this single data point as an imminent, scalable solution for providing clean energy to the global power grid. But the actual physical mechanism utilized in this experiment was inertial confinement fusion, executed on a target pellet the size of a peppercorn. The reactor fires an array of highly precise lasers directly at this microscopic target, compressing it until it triggers a localized, contained microexplosion. This methodology lacks a demonstrated path to the scale and repetition rates necessary for commercial power generation. At its current stage, it is a tool for studying nuclear weapons physics, not a blueprint for an industrial power plant. Furthermore, the headline of a net positive energy yield relies on a specific omission. It only calculates the energy delivered by the lasers to the pellet versus the energy released by the pellet. It completely excludes the immense amount of electricity required from the grid just to power the lasers themselves. These data bars compare the final output of the microexplosion against the massive energy draw of the surrounding infrastructure required to compress it. Presenting a military context microexplosion as a scalable energy solution is a contextual fallacy, incentivized by the pursuit of media attention. When constant hype inevitably gives way to retractions, the collateral damage is a degraded public trust. Observers begin to wonder why they should fund scientific enterprises if the results are always in turmoil. To navigate the noise, you have to mentally divide all scientific claims into two strict categories: established knowledge and theoretical speculation. The established body of knowledge consists of physical mechanisms that have survived decades of independent replication. They are the solid structural foundation of physics. Speculation, on the other hand, consists of tentative hypotheses. They often possess elegant mathematics, but they currently have zero physical evidence backing them up. The structural problem we face today is that researchers, universities, and the media are all incentivized to disguise those floating, unproven speculations as foundational blocks. Fortunately, over long enough time horizons, the scientific method strictly self-corrects. Measurement artifacts, mathematical errors, and unit-scale discrepancies simply cannot survive sustained peer review. Rushing a data analysis or circumventing independent verification might capture a media cycle in the short term, but it will never survive the decades of testing required to validate a theory. The communication network surrounding science is flawed, often prioritizing sensationalism over accuracy, but the underlying mechanism of physical validation remains the most reliable tool for uncovering the truth. True scientific progress isn't measured by paradigm-shifting headlines. It is measured by the quiet, enduring expansion of verified physical truth.